Hi, you rates. Today what we're going to do is we're going to do a quick revision session on a section in your book called 9.1, which is reactions of acids. And it's very important to remember why it is that we have to study acids. Acids are everywhere. We can actually see very dilute acids in rain. We can see the damage that they cause to plant life and statues. Very concentrated acids are used in car batteries. Now, if we were to touch them, they would corrode our skin, our tissues and bones. When we have to handle them, we handle them with full protection. So acids are a part of everyday life and we must understand their key reactions. So let's have a look at the material. The first thing that I'd like you to do is I'd like you to make sure that you know the difference between corrosive and moderate hazard signs. Now, to really get the most out of this topic and the next couple of topics that you have to revise, I would suggest that you go to your workbook. And I've shared a revision map with you during the lesson when we were in school, and you can see the matching of the three signs, the three hazard signs that you have to have prepared for your summer term assessment. So figure 2 shows acids can be corrosive. So the one on the left hand side is corrosive. You can see exactly what that's doing to a piece of metal. Maybe it might be a bit of wood, and then you've got a hand and it has exactly the same thing, so it corrodes through, it actually reacts with the surface. If it's a low concentration, then we would put this hazard label on it. This is just a moderate hazard. Okay, a moderate hazard could cause us harm, but it's not going to kill us. Okay, there are patterns in the way that acids react with different metals, different carbonates and different alkalis. So with different chemicals, what we need to do is, first of all, we need to make sure that we're very, very clear on three very important and very common acids that are there at key stage 3. Hydrochloric acid, formula HCl. Remember, you must make sure that you put the capital C and a little l for hydrochloric acid. Please make sure that you spell hydrochloric correctly as well. Sometimes I see that misspelled. Now, hydrochloric acid always gives chloride salts. You can pause the video while I'm holding this camera above the book, I should say. Nitric acid has the formula HNO. Look at the 3; it's below the line, okay? And that gives nitrate salts. Sulfuric acid, we do spell it with an F now. So sulfuric acid is H2SO4. See how the 2 and the 4 are below the line, okay, and that forms sulfate salt. So make sure that you understand that. Now, acids react with many substances, but one common product is formed, and that is a salt. So we'll have a look at 3 different reactions that form a salt, as well as some other products or product. Now, salts always have the same type of name. The first part of a salt is actually the name of the metal, name of a metal that's involved, and the second is based on the acid that has reacted to form it. So, very basic, first, very simple reaction that we have studied. We've done this in practice as well. Acids and metals. Okay, so acids reacting with metals can actually form metal salt. Here we have the zinc chloride, so make sure that you look at your exercise book. You'll see this, but anyone who's just watching, I'm teaching it to you right now. So zinc chloride, because the name zinc chloride has the first word, which is zinc, and that comes from the metal itself. Now, hydrochloric acid, remember what we saw in the table? So hydrochloric acid forms chloride salt. So we have zinc chloride. Okay, now whenever you have an acid reacting with a metal and the reaction takes place, you do form bubbles, you do see fizzing. That's the evidence of a chemical reaction taking place, and the bubbles are actually hydrogen gas. Now have a look at how we confirm that the bubbles of gas formed are hydrogen. Now, the test is called a squeaky pop test. That's the observation. But to do the test, to carry the test out, make sure that you don't get caught out with that. You need to have a wooden splint. It needs to be lighted. So if you forget in your test that you need a wooden splint and you need to give an answer for that, what you need to do is you need to say that you've got a flame. Okay, so you could say flame. And when you actually when you actually collect this hydrogen gas, you can collect it in a test tube. So you let it fizz for a little bit, just pop a cover over it, or what I like to do personally is I like to put a boiling tube over it and collect it. And then what you do is use the flame, and you get a bang. Okay, so you can get get some marks by saying that you need to use a flame, and you get an explosion. That's the observation. That bang, that explosion is on a miniature scale, and it sounds like a squeaky pop. Okay, so let's go back to zinc and hydrochloric acid. Now here's the word equation. Zinc, see how it's got the words? Zinc plus hydrochloric acid reacts to form. Make sure you've got an arrow there. Okay, no equal signs. So zinc plus hydrochloric acid reacts to form zinc chloride plus hydrogen. Now zinc is Zn, it's an S. 2 HCl are required. That's 2 H's and 2 Cl's. So 2 hydrogens, 2 chlorides, okay? Then you have zinc chloride. So the 2 chlorides go from here to here. So you can see there's 2 of them here. You start off with one of the zincs. You end up with 1 zinc in the metal, okay? And there's a hydrogen there, okay? And those 2 hydrogens come from the 2 hydrogens that were here. Simple equations always have the state symbols. That's S for solid. AQ means that this hydrochloric acid is diluted in water. Same there, that zinc chloride is in water. And a G is for gas. Now, let's go to the second reaction. We've got acids plus metal carbonates. Okay, so the metal carbonate here is copper carbonate. Okay, so you add copper carbonate to sulfuric acid. Can you remember the type of salts that come about when you use sulfuric acid? Right, it's a sulfate salt. So the name of the metal in this compound is copper. So can you put together the name of the salt that you form? You've got the metal there, and you've got the type of salt. Copper sulfate, okay? So copper sulfate will be one of the products. Now it's carbonate. Now carbonate contains carbon and oxygen, okay? So the carbon and oxygen will produce carbon dioxide gas. And the final thing is that the sulfuric acid is a source of hydrogen. It's a source of hydrogen, positive hydrogen ions. So that hydrogen will combine with some of the oxygen in the carbonate, and that will form water, H2O. Here we go. Bubbles of carbon dioxide gas, that's the sign of a chemical reaction that's taking place. The liquid turns blue because you actually have copper sulfate formed. You can't see the sulfate, but you can see the copper ions in there. How could we test that carbon dioxide gas? You can collect the gas in this upturned test tube, which is full of lime water. It will go from colourless to cloudy. Make sure that you have the signs there, okay? And to confirm that the bubbles of gas formed are carbon dioxide, test the gas in lime water and observe that the lime water becomes cloudy, okay? Right, so word and balanced symbol equations, okay? So I'm expecting you to be able to understand this, so pause it if you need to, okay? So you got copper carbonate, that's the name of the solid, okay? That's that. Sulfuric acid forms copper sulfate, that's diluted in this solution here, that's why it's got an AQ there. There's some water because the hydrogen and some of the oxygen combine together, H2O. You got carbon dioxide, and that comes from the carbonate. That's what forms a carbonate, okay? It's CO3, okay, CO3. So 2 of the O's form the oxygens in carbon dioxide, and 1 of the O's is left over. 1 O, 2 H's form H2O, okay? The copper goes there, and the sulfate, which is a spectator ion, the sulfate goes there and it combines with the copper and it stays in the solution. So copper carbonate, which is a solid, aqueous solution of sulfuric acid, so it's sulfuric acid dissolved in water, okay? And then you've got it reacting to form, so you've got the arrow, copper sulfate, which is in this solution, water, which remains in the solution as well, and when we say water is in the solution, water is actually a liquid because it's water in a solution of water. So we always actually say that water in a chemical equation, in a symbol equation, is a liquid, okay? And the final thing is the gas of carbon dioxide that comes off. Now, the final thing that you need to know about is acid plus alkali. So an acid always reacts with an alkali, such as a metal hydroxide, to produce a salt. So that's the third time a salt has been produced, and water, okay? A salt and water. Can you remember what type of salts form from nitric acid? Which one of these salts? It is nitrate salt. So here's the name of the metal, sodium nitrate forms, okay? So sodium nitrate's there, all right? And the hydrogen from the acid and the hydroxide, which is OH, so the hydrogen from the acid and the hydroxide, which is OH, combine to form two H's and an O. So it's a molecule with two H's and an O. So that is water. Can you remember what state symbol we use? The reason why we use that? We use L because it's water and it's water in water. So we call it a liquid. Okay, it's a chemical. But we just say that the water is in its liquid form. Okay, so nitric acid, that's the formula for nitric acid. Sodium hydroxide, there it is. Sodium nitrate, that's the salt because you've actually got the nitrate part from the nitric acid going there. And then you've got the sodium part from there to there. And then you've got water, okay? All right, that is actually a balanced chemical equation. Number of sodiums on each side. Remember that sodium is an Na, okay? So number of sodiums, number of oxygens, number of hydrogens, you can count them up. They're equal on both sides, okay? We don't use an equal sign though, okay? We use an arrow. This is a neutralization reaction, so once the acid completely reacts with the sodium hydroxide, assuming that you have as many H's here to combine with OH's there to form water, you will then get complete neutralization. The solution will have a pH of 7, okay? You can predict the name of the salt, remember, from last time, but from this table over here, but if you had sulfuric acid plus calcium hydroxide, that would give you calcium sulfate, sodium nitrate from sodium hydroxide, as we've said, and nitric acid. Okay, so over to the questions. There's quick questions to test your understanding. Which substance reacts with acids to make hydrogen gas? Okay, pause the video. The answer is metals. Gas produced from an acid reaction turns lime water cloudy. What gas was made? Pause the video. Carbon dioxide. What products would you expect if potassium hydroxide reacts with nitric acid? Pause the video. Potassium nitrate and water is the answer. Which two chemicals reacted to make these three products? Calcium sulfate, water, and carbon dioxide. Pause the video. So you got carbon dioxide, so it's definitely a carbonate. And it's a calcium carbonate because you have made it from calcium sulfate, and you're making sulfates, so it must be calcium carbonate and sulfuric acid. Okay. Number 5. Let's have a go at number 5. Write a balanced chemical symbol equation including state symbols for the reaction of calcium with hydrochloric acid. And there's the formula of calcium chloride. Pause the video. So it would be Ca plus 2HCl reacts to form CaCl2 plus H2. Okay? Best of luck. Move on to the next video. See you year 8.